Hey everyone, today we're going to explore a fascinating problem. Given a number n, how do we figure out the least number of perfect square numbers whose sum equals n? For example, 12 can be represented as 4 plus 4 plus 4, which is 3 squares. By the end, you'll know how to solve this efficiently using JavaScript. Here's the challenge. Suppose you have a number like 12. You want to express it as a sum of perfect squares. Numbers like 1, 4, 9, 16, etc. The goal is to use the fewest number of squares. So, for 12, we can do 4 plus 4 plus 4. That's 3 squares. For 13, we can do 9 plus 4. Only 2 squares. We'll see how to find this efficiently for any number. Here's the JavaScript solution. We used an array called maps to store the minimum squares needed for each number from 0 up to n. For each number I, you try subtracting all perfect squares smaller than I and see which combination uses the fewest numbers. Finally, maps n gives us our answer. This is a dynamic programming approach that's very efficient. Let's walk through the logic. First, we prepare an array to store the least squares for each number. Then, for each number I, we assume the worst case, that is just one more than the previous number. Then, we check all perfect squares smaller than I, and then update maps I if we find a smaller combination. In the end, the last entry in the array gives us a minimum number of perfect squares for n. Here's how it works for some examples. For 12, the answer is 3 because 4 plus 4 plus 4 sums up to 12. For 13, the minimum squares are 9 plus 4. For 63, we use 49 plus 9 plus 4 plus 1, 4 squares in total. By storing intermediate results in the array, we efficiently calculate these results without trying every combination manually. This problem isn't just academic, it's also used in number theory and in computer science for optimization problems. Learning to solve this builds strong dynamic programming skills, which are useful for solving puzzles, algorithm challenges, and even applications in cryptography. To conclude, we've learned how to find the smallest number of perfect squares that sum to a given number. Using dynamic programming, we can use this efficiently for any number. We've also seen real-world applications from puzzles to optimization problems. This is a classic example of how breaking a problem into smaller pieces makes coding easier and more powerful. Thank you for watching. If you enjoyed this video, please make sure to like, share, and subscribe for more JavaScript tutorials. I'll see you in the next one.